Separation of variables and integration. This is the easiest method to solve first-order ordinary differential equations. If an ODE is separable, it can be put in the form m of x plus n of y dy by dx is equal to 0. So here m and n are continuous functions. Let's solve this to show you how we would do it. So the first thing is we would take away m of x on both sides. From there, we integrate both sides with respect to x. So here we've taken away m of x. I'm going to integrate with respect to x. So the integral of ny dy by dx equal to the integral of negative mx dx. Now, looking at this, we can observe that we can cancel dx by dx. This is the only time you'd call that cancelling. This, so that makes it the integral of ny dy is equal to the integral, we'll take the negative outside, of mx dx. There we would just integrate it and then make y the subject. So let's have a look at an example. Say we have the differential equation x plus 3 plus 4e to the y dy by dx equals 0. So here our m of x is going to be x plus 3 and n of y is going to be 4e to the y. So let's put brackets around this, and that makes everything so much easier. Our first step is we're going to take away m of x. So that will give us 4e to the y dy by dx is equal to negative x plus 3. Now we can integrate both sides with respect to x. So the integral of 4e to the y times dy by dx is equal to negative integral of x plus 3 with respect to x. Now we can cancel the dx's, so we've got the integral of 4e to the y dy is equal to negative integral of x plus 3 dx. Now the left hand side just goes to 4e to the y, and the right goes to negative a half x squared plus 3x. Now we want to make y the subject, so we're going to have e to the y is equal to negative an eighth. An eighth x squared plus 3/4 x, and then y is equal to the natural logarithm of negative an eighth. It's going to be x squared plus 3/4 x, and don't forget the plus c, our constant of integration. That's technically a different constant, and that is separation of variables and integration. So now we're going to have a look at a more challenging example. So this is a question dy by dx equal to 4 minus 8x plus y minus 2xy. Now this is not in the standard form, which you'd recognise to separate. So the first thing I would do when I see this question would be to see if we can factorise the right hand side. Are there any common factors? So we're going to take out this y first of all. So if we have 1 plus, that should be a minus. 1 minus 2x plus 4 minus 8x. Now, having a look at both this bracket and the 4 minus 8x, 4 minus 8x is a multiple of 1 minus 2x. So if we write it as 4 lots of 1 minus 2x, then we can see that we can take out the factor of 1 minus 2x from everything, and that gives us y plus 4. So there we've just factorized this into 2 brackets. And we can see that on the left bracket we've got only functions of x, and on the right only functions of y. This means that we can now do our separation of variables and integrate. So if we divide by y plus 4 on both sides, then we got 1 over y plus 4 dy by dx is equal to 1 minus 2x. And you can see we're now on to what was before, I believe, step 2, where we have got this, and we can just integrate with respect to x on both sides. So we've got the integral of 1 over y plus 4 dy by dx. Dx is equal to the integral 1 minus 2x dx. Cancelling with the x's, and then it's just a simple integration which gives ln y plus 4 equal to x minus x squared plus c. Then the last bit, I'm going to have to go over onto the right hand side. We just have to make y the subject of the equation. So we're going to use the exponential function e to the x minus x squared, and I'm going to put plus k, a different constant. And then y, finally, is e to the x minus x squared plus, oh no, it should be a multiplied by k, shouldn't it? Apologies there. K, because we've got the constant added in the power, it should be multiplied by, once it's out of the power, and that is minus 4. And that is separation of variables and integration, and that was a more challenging example. Thank you for listening.